Hello, my name is Chori Min from Seoul National University. In this presentation, I and my collaborators present a paper titled GATSBI. What is the best form of representation that describes the scene consists of the agent, objects, and background? How can the agent infer proper action from such entangled observation? As the action is directly correlated to the agent in the scene, finding the explicit representation of the agent can be a preliminary building block for vision-based intelligence. In the context of object-centric representation running, we can embed the entire observation as a composition of an individual entity. One of the two widely used methods of object-centric running is an attention-based model that captures the scene entity from the coarse grid representation of a scene. The other method is a Gaussian mixture model that formulates the scene as a mixture of entities whose weight is an image-sized spatial mask, and the Gaussian is a color distribution. While the representations for objects are widely studied, the representation for the agent, which is actively moving in the scene, still remains ambiguous. In a sequence of observations, the agent is actively moving according to each sequence of actions. Consequently, an object can be passively moved from the interaction with the agent. Meanwhile, the background entities usually remain steady. Motivated by these properties, we aim to find the scene representation that is based on the property of the agent, objects, and background. To find such representation, our model GATSBI is first given with an observation and corresponding action. Then the combination of mixture, keypoint, and object module extracts latent representations of the agent, objects, and background, then models the interaction between them to update the object states. This inference procedure is repeated for each step, leveraging temporal states of RNN. GATSBI captures the agent in the following manner. Given the observation, RNN state, and action as an input, the mixture module of GATSBI decomposes K entities that have large and complex morphology like the agent. As a result, we get K latent variables that describe masks and components of each entity. Though the agent morphology is captured by the mixture module, its index cannot be identified by the mixture module itself. How can it specify the index then? The specification of agent index is done in the Keypoint module. Due to the nature of Keypoint module that captures the moving entities in the scene, it infers a set of keypoints that describes the actively moving agent. We then generate keypoint heat map gamma and compare it with the mask pi, and specify the index of the most similar mask to the keypoint heat map. Further, we construct a shared dynamics between the keypoint module and the agent entity to coordinate the dynamics between the keypoint and the agent mask. Our object module adapted from previous work discovers and embeds the remaining small object entities. We also have latent embeddings of the agent and the background reconstruction acquired in the previous step. For each object variable, an agent-object interaction is constructed. In addition, the passive dynamics between objects and static relationship with the background are also considered. The final interaction for each object is the sum of the three terms, and it updates the dynamic state of each object. Now we show the experimental results. We test GATSBI on 3 simulated datasets and 1 real-world dataset. And we compare GATSBI to the state-of-the-art baselines to our method. For the temporal prediction results, GATSBI and its baseline predicts future agent-object interaction sequence given 5 frames. We can see that GATSBI predicts future frames that is very close to ground truth future frames. For the spatial-temporal prediction, we can see that the spatial decomposition of the scene into the agent, background, and objects is consistently propagated through time for all datasets. In this work, we propose a method to model agent-object interaction from videos. Our method GATSBI decomposes a scene into the agent, object, and backgrounds. Experiments show that GATSBI has learned accurate dynamics of the agent-object interaction. However, there are some limitations that we are intrigued to improve upon. Thank you for your attention.